The slope of a line, lesson 8-4. Remember to take notes. You want to look for the learning target, and you're going to write down examples, key vocabulary. Come to class with any questions you have, please. How do engineers build bridges? So we're looking at this. What does this have to do with math, right? And looking here, we can see some more math happening. Let me see if I get my arrow. So we see some angles, we see the supports. So let's continue. How do engineers build roads? We see that we have a decline going down here. How can we write 7% as a fraction? So this is showing us a 7% grade. And so how could we write that as a fraction? Let's see, we can write 7 over 100, right? And we know that from, well, just knowing it probably, but also as we've just finished up percents. So we could write it like that. So this would mean what? This is going to have a special meaning to us a little bit later. Okay. Oh, look at that. I didn't even need to do that one page. So we rewrote this as 7% equals 7 over 100. Here I said it's got a little bit of meaning to us later. So we're showing an incline this time. However, we can see the car starting down here and he's going up. For every 100 feet he goes across, he's going to go up 7 feet. So we could write this as 7 over 100. He goes up, so we can say he rises for every 100 feet he runs, or he drives in this case. So we have a rise over run. So we put rise 7 feet over our run. So we know that he's going up 7 feet for every 100 feet. We're going to have a very special name for this, and this is called the slope. So when you see on a road that talks about a 7% grade as you're driving, that means for every 7 feet up you go, you've traveled 100 feet, or basically for every 100 feet you've driven, you'll increase 7 feet, or maybe decrease 7 feet, depending if you're sitting up here going down the hill, or if you're like a little car and he's coming up the hill. So this is our slope. Slope is rise over run. And you'll see this again in other slides here. But make sure you get this down because this is something you're going to really need to know for all of our linear functions. The slope is rise over run. So rise is the up and down, how much you're going up or how much you're coming down. And run is the distance from the horizontally, from the starting point to your end point. Make sure you pause as you need to. Let me look to see if I can erase this. Let's see, I'm trying to make it a little bit fun, right? Oh, something else is just popping up in my little window down here. Okay. And I know if I don't get all of it, some of you I will be driving absolutely crazy. Oh, see, I missed a piece. Okay. Oh, good, it went away with that. I don't have to. Cool. So slope of a line. The slope measures the rise and the run of the stairs beneath. So the rise is the vertical chain. So we're going to call this the rise because that's the vertical. It's the up and down. And the run is the horizontal. It's the left to right. You need to make sure you get this in your notes. This is really, really important. Okay. So we have stairs. And the stairs are all together, they form a line. So you can see the line right here. And if any of you have ever actually built a deck or help someone build a deck, or you go to the home improvement store, Home Depot, Lowe's and such, you'll see risers, as they'll call them, for building stairs. And they look like this, except usually they're wood and they're one color, but they have a straight edge here. So this is the line. And this is how this is moving. This is our rise. and this is our run. And you'll hear people talk about the rise and the run of stairs because we are very used to a certain pattern when we're stepping. And you'll notice that when you walk in some people's stairs, you'll feel like you've stepped too far or the step was too close, and you'll notice those little things. So the rise and the run is how this is going to be, how steep these stairs will end up being. Okay, I told you this is the formula. So to find the slope, you're going to use this formula. Rise over run is slope. M is now what we call slope. Whenever you see M, you know that's the slope. So if I have y equals mx, you know M is my slope. You're also going to know x is a coordinate point and y is going to be a coordinate point. We'll practice that a little bit here soon. But M is my slope. In fact, if you remember, I had you skipping a little bit of the direct variations. This is a direct variation. Whatever M is going to directly impact when I multiply x what y will become. So make sure you're getting some of this down. Here's a cute little quote. I thought it was going to be larger when I actually typed it, so I apologize that it's hard to read. Let's see if I can get it to be bigger. No, I don't know how to do that with software. Okay, still learning. But anyhow, it says you must rise before you run. So look at the little girl, a little child, could be a little boy, I don't know. And they're rising, they're standing up before they can run. So you've got to rise before you can run. This is really important. This means your y values, your y is your rise, your up and down, is going to be over your x. This is your rise and run. And we're actually going to talk about change in x and change of y, and we'll get there. But right now I need you to know rise over run. So you're going to look at your how you're moving up and down versus how you move left to right. Okay, slope of a line. To find the slope, you use this formula. So remember, this is my rise. So that's my 4, this way. Let me change colors just so that we can, okay. And this is going to be my run. And you can almost read that, right? And this is my run. So 4 over 4, or it simplifies to 1. Let me put that in a different color. There. It simplifies to 1. That means if I'm moving along the coordinate points, every 1 up I go 1 over. Every 1 up I go, 1 over I go. Up 1, over 1, up 1, over 1. Obviously not to scale, right? This moment I'm going to stop this video. There will be additional parts to this, so make sure you come back to watch part 2.